Happy Fibonacci Day, 11/23, November 23rd, 1123. 1123 are the first four digits of the Fibonacci sequence, so that's, I suppose, why mathematicians celebrate it. Now, Fibonacci wasn't the first to discover this. It was revealed hundreds of years prior by Indian mathematicians, and if you probably go back to ancient Egypt, it was known back then. But for whatever reason, Europeans have stamped it Fibonacci, so we celebrate Fibonacci Day on 11/23. Or maybe we can just celebrate the concept of spirals in 2 dimensions or vortices in 3 dimensions. Either way, it's still exciting. So, the Fibonacci sequence mathematically describes spirals in nature. So there's this concept of a spiral going around and around, and with vortices going up or down. And we have this in seashells, sunflower seeds, patterns in pinecone seeds, spiral galaxies, and so on. Now the sequence is very simple, or the pattern is very simple. It's a recursive pattern, a recursive fractal pattern. So basically you take any number within the sequence is the sum of the two previous numbers. So you just keep going along like that. So the first number in the Fibonacci sequence, or what I call Phi Series 1, is actually the number 1, but it is seeded prior to that with the number 1. So that's why the sequence starts 1, 1. If you go to the Lucas series, again it starts with a 1, but it is seeded with the 2, so it starts 2, 1. So the Fibonacci sequence goes 1, 1, and then the next number is 2 because we add the 1 to the 1, and then 1, 2 equals 3, and so on. So this is the pattern. This is the pattern that has been known for a long, long time and is the most common pattern within this sequence. And there is this ratio between adjacent segments. So between any two numbers in this Fibonacci sequence or this Phi Series 1 sequence, this ratio can be measured and it changes over time. So initially we just have the 1 and the 1. So 1 divided by 1 is 1. But as you progress to larger and larger numbers, the ratio between two adjacent numbers converges on what they call the Phi ratio, or the Phi golden mean ratio, which is 1.618, It's an irrational number, so it continues. So that is the main pattern, this fractal pattern. Other patterns have been discovered, namely, I guess a really important one, at least for me and my work, is the concept of 24 repeating digits in these sequences, these Fibonacci sequence or the Lucas sequence or the other 7 Phi series sequences. Now it's not that the actual values repeat because they don't. They just keep increasing. So 1, 1, 2, 3, 5, 8, and it just keeps going. So and it grows rapidly. So that doesn't repeat. But what does repeat is when we reduce it to a single digit. So we can take any number beyond 9 and reduce it to a single digit. So if we have the sequence 1, 1, 2, 3, 5, 8, then 13, we will reduce the 13 to a single digit. 1 plus 3 equals 4. And then the next number is 21, reduce it to a single digit, it's 3. And so what you'll find is that you will find this pattern of 24 repeating single digit numbers. So the 25th number is a 1 because it's the same as the first pattern. So we have this micro pattern, this microfractal pattern of every number is the sum of the previous two numbers. And we have this macro pattern where you have this 24 repeating cycles. Now, with respect to this micro pattern, it's generally thought that is the pattern that defines growth. Somehow there's a blueprint that says, let's just sum the two previous numbers to create the actual next one. And while that is true, there's actually another blueprint that underlies that. So underlies that is driving all of that. And it is the blueprint of numbers, of just base numbers. So what I found along my exploration of numbers were a series of numbers that seem to, be involved in many, many systems. and they were very interrelated within themselves and interrelated with other numbers. But of this larger set of numbers, 3 of them are very specific to the Fibonacci series, the Lucas series, or the Phi series, this kind of fractal growth pattern. And these 3 numbers are 72, 137, and 161. And what I found is that you can take these 3 numbers and you can sum them in different proportions or multiply them in different proportions, and they will equal every single Fibonacci number, every single Lucas number, every single Phi series number. And I'll show you the actual mathematics of that in a moment. So what I like to refer to this spiral pattern is a soup, and the ingredients are these 3 numbers. So the 72, the 137, and the 161. So these are the actual 3 main numbers that underlie this type of growth, this type of fractal growth, additive growth, let's say. Now the 72 is, I kind of refer to that as a stabilizing force, okay? A stabilizing force, a stabilizing structure. It has references to geometry. For example, a circle is composed of five segments of 72. So 5 times 72 is 360 degrees. 72 is also a trinity of 24, and 24 for me is a complete cycle. So you have a trinity of 3 complete cycles. So you can imagine 3 circles in the form of a triangle, a trinity. So the triangle is this very stable structure. So I kind of see 72 as a blueprint for as a stable structure that helps define growth. Now on the other side, we have this 161. And 161 refers to the actual concept of growth. Now the Phi golden mean ratio is 1.618033, and it continues on forever. But the core number, or this core pattern of growth, this core energetic signature of the Phi ratio, is actually 161. If you just remove the decimal places. So we have 72 is a stabilizing structure. We have 161 is the blueprint for growth. Now in between that, which is kind of the glue together that holds the structure and the growth together so that it moves in a beautiful harmonic pattern in nature, is the 137. Now the 137 is are important concepts within Kabbalistic teachings. So this is the mystical side of Judaism. So you have the 1, the 3, and the 7, and they all form different aspects of our reality. The 1/137 in physics represents the push and pull forces of electromagnetically charged elementary particles. So we have this push and pull force in the middle with the 72 on one end, the 161 on the other, 137 in the middle. And so these 3 blueprints, or these 3 ingredients, form this spiral soup, or a vortex in 3 dimensions. So why don't I show you the very, very simple math that is behind how these blueprints form these numbers, the Fibonacci, the Lucas, on all the Phi series numbers, and then we'll wrap it up. Okay, so here we have the 3 Phi blueprints, 72, 137, and 167, which I spoke about earlier. And combinations of these three Phi blueprints create all Phi series. Here we have Phi Series 1, known as the Fibonacci series, and I have listed out 12 positions and the values, so 1, 1, 2, 3, 5, 8, all the way up to 144 at the 12th position. And I've just calculated the values for at the 10th, 11th, and 12th position, so 55, 89, and 144, using the combinations of the 3 Phi blueprints. 72, 161, and 137, except in this case, and the Phi Series 1, the Fibonacci series, is unique among all the other 9 series, and then you actually only need the Phi blueprints 72 and 161 to derive the values. So if we look at 55 at the 10th position, it is equal to 3 times 72 plus minus 1 times 161, and that will equal 55. For 89, it's minus 1 times 72 plus 161. That equals 89. And for 144, very straightforward, it's 2 times 72. If we go to the 24th position, which is 46,368, it's actually equal to 322 times 72 plus 144 times 161, and that will equal the 46,378. So the 72 and the 161 Phi blueprints are the only two out of the three that are required to generate any and all Phi Series 1 Fibonacci numbers. In this table, I've listed out the first 9 values of Phi Series 1, or the Fibonacci series, and the multipliers, or the coefficients, that are required against the 72 and the 161 Phi blueprints. So if we look at the first value at position 1, it's actually equal to minus 199 times 72 plus 89 times 161, and that will equal 1. And if we go all the way to the 9th position value of 34, it's equal to minus 4 times 72 plus 2 times 161, and then that will equal 34. So here is a very simple equation. You basically have a coefficient for each of the multipliers, and then you sum these together and you will get a Phi Series 1 value. Here we have Phi Series 2, otherwise known as the Lucas series, which is seeded with a 2 instead of a 1, as in the Fibonacci series. I've listed out 9 series sequences with the values going from 2 to 47, and the coefficient, or the multiplier, for each of the 3 Phi blueprints. So we can take the value 2, which is the first position value, and it equals minus 110 times 72 plus 1830 times 137 plus minus 1508 times 161, and that will equal to 2. And you can do this for all Phi Series 2 values, the Lucas values, just as you could for the Fibonacci sequence. And one thing you'll notice is that these coefficients, whether they're the coefficients for the 72, the 137, or the 161, they all follow the pattern of a number is the sum of the two previous numbers. So if we look at the coefficient for 72 at the second position, so that's minus 110 right at the top. If you go minus 110 plus 68, you get minus 42. And then if you take 68 minus 42, you get 26. Similarly, we can go to the 137 coefficient at 1830, just at the top again. We can go 1830 minus 1,131, and you'll get 699, and so on. And you can do this the same for the 161 coefficients starting at 1508. So all of these also follow that micro pattern that a number is derived from the sum of the two previous numbers. So far we've covered Phi Series 1 Fibonacci and Phi Series 2 the Lucas. Now I will just round this up with Phi Series 3, and it will be the same for the rest, for Phi Series 4 all the way to 9. There are 9 Phi series. So for Phi Series 1, you only needed the 72 and the 161 Phi blueprints. For Phi Series 2 all the way to 9, including the 3 here, seeded with the 3, you need all 3 Phi blueprints. So we can start at position number 1 at the seeded value 3, and that is derived by multiplying negative 1008 times 72 plus 699 times 137 plus minus 144 times 161. And when you add up those 3 values, it equates to the value 3. And you can do this for all of the Phi Series 3 values. And again, the coefficients are equal to the sum of the two previous numbers. So if you look at
the coefficients for 161, starting at the top at minus 144 at the first position. You can see minus 144 plus 89 equals negative 55. And 89 plus minus 55 equals 34, and so on. You'll also notice that those coefficients at the 161 are identical to the actual Phi series values themselves, except in this case it oscillates between positive and negative values. We have three blueprints underlying all Phi series, 72, 137, and 161. And the values in the Phi series, including Lucas and Fibonacci, can all be derived from simple algebraic equations, where you simply have a Phi blueprint, you multiply by its coefficient, and then you add the Phi blueprint for 137 and its coefficient, and then you add the Phi blueprint 161 times its coefficient. So here we have the omega, which coefficient times the omega blueprint. So omega, I've assigned that to 72, and alpha coefficient times the alpha blueprint, and alpha I refer to that as 137, and this is just keeping in line with the symbol that is used in physics, and then phi coefficient times phi blueprint. And so this simple equation will define the Phi series values, and in the case of Phi series 1, it just simply omits the 137 blueprint. Just to reiterate a little bit about these three blueprints, the 72 for me is related to structure, in this case a triangle. 72 is a trinity of a complete cycle, so a cycle being a circle, and so we have three circles forming a triangle. So that is which is a very stable structure. It's also related to geometry in general. 5 times 72 equals 360 degrees for a circle. And 72 is also the exterior angle of a pentagon. 72 is related to music and sound. 6 times 72 equal to the 432 harmonic frequency. 72 is also related to many other things in our culture, including the Earth's axial precession, which shifts 1 degree every 72 years. The second Phi blueprint, 137, has meaning in different aspects of our culture. In physics, it characterizes the strength of the electromagnetic push and pull between elementary charged particles, like electrons and protons. The angle, 137.5, determines the optimum arrangement of seeds for packing and leaves for sunlight exposure. So we have a concept of symmetry, optimization, and recursion. And spirals represent growth, recursion, and symmetry. And 137, the energetic signature, or that energetic blueprint, is part of that type of growth. Lastly, we have the blueprint 161. Now the Phi ratio, which is a ratio between adjacent segments or adjacent numbers in these Phi series, is equal to approximately 1.618033. In this case, the 161 is the energetic signature of that Phi ratio. It represents spiral growth, and spiral growth is all about self-symmetry, which is the same spiral structure at different scales. So you have recursive scaling, basically. The same scaling rule is applied at each step of the spiral's expansion. One interesting quirk about these three blueprints is the relationship between the 72 and the 161. If you take 161 and divide it by 72, you actually end up with the square root of 5. And the square root of 5 is the equivalent of the Phi ratio plus its inverse.
So there you have it. Very simple, very elegant. 3 blueprints, which are called the Phi blueprints, 72, 137, and 161, that underline all this spiral growth pattern, all this fractal recursive pattern of these spirals and vortices. If you want a deeper dive, or maybe a larger description of these Phi blueprints in action, I will put a link in the description or the comments that will link to my website, arianwei.com, and there is a section called resources with articles, and you can link to just a paper I wrote on that, which I published on a preprint server called Zenodo, and you can take a look at that and possibly find some proofs or some derivations if you're into mathematics that can solidify this concept of these three blueprints.